Bismillahirrahmanirrahim. Assalam O Alikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus, National Book Foundation, Physics SSC2, Unit number 10, Simple Harmonic Motions and Waves. SLO base and FBISC requirement questions. Today we will solve the short question number 6 to 10. In previous video, in part 1, we can solve the question 1 to 5. In question number 6, given statement, some masses are attached to a different spring. One is vibrating faster. Why? First of all, we write the answer. A shifter or a stronger spring mean a great force in according to the Newton's second law of motion. According to Newton's second law of motion, F is equal to ma. For a given mass, that mass is greater, so the acceleration of body will be faster. A greater acceleration, so the mass will be move faster and therefore complete its motion quicker in short period. Now, another answer for the justification of this question we have. Thus, if the mass is double, the time period will be increased by a factor of 2 square root. So, a mass is hanging from a spring pulled down from its equilibrium. Now the equilibrium position through a distance a and then released at a time t is equal to 0. Now in question number 7, the given statement, a simple pendulum has a time period t in Murray and in Karachi it is different time period. What would you to make it time period same it was in Murray? So this question, the time period t is given by the expression t is equal to 2 pi L over g. In simple pendulum, we can find the time period by the formula t is equal to 2 pi L over g. So t is inversely proportional related to the value of g at a place. At Murray, the value of acceleration due to gravity is less than at Karachi. Hence the result. So, another answer for this question, now we can say that height of Karachi at sea level to 500 meters, whereas the height of Murray is 2291 meters. Therefore, G has smaller value in Murray than Karachi. So this is the reason for a time period. As T is inversely proportional to the acceleration due to gravity, the value of G. Therefore, the time period of the simple pendulum will be increased in Murray as compared to Karachi. So, in question number 8, what will be happen to the frequency of wave in a ripple tank if the time period of electric vibrator is decreased? What will be happen the wave of speed? So method, set up the ripple tank as shown in a diagram with just 5 centimeter deep of water. Adjust the height of wooden rod so that it just touch the surface of water. Switch on the lamp and motor and adjust the speed of motor until the low frequency wave can be clearly observed. So, another answer for this explanation, we can see that the frequency of wave is increased. Describe what will be the happen of the speed and the wavelength of the wave? So the answer is that question, the speed would be stay the same and the wavelength would be decreases. Now we will move the question number 9. In question number 9, why do the water wave refract at the boundary of shallow water and deep water in a ripple tank experiment? So we write the answer, waves change the speed when they pass occur the boundary between the two different substances, such as light wave refracting when they passing from air to gas. This cause then to change the direction, and this effect is called rarefaction. Water waves refract when they travel from deep water to shallow water and vice versa. So another answer, so in this answer we can see that when traveling from deep water to shallow water, the waves are seen to bend in such a manner that they seen to be traveling more perpendicular to the surface. If the traveling from shallow water to deep water, the wave bend in the opposite direction. And another answer for this question, we can see that a deep water wave is one of the occur at deepest greater than the half of the wavelength. A shallow water wave is the one of occur at the depths shallows. Then the wavelength of the wave divided by 20. We can explain more. Speed in meter per second is equal to 3.1 multiplied by square root of depth in meters. So we have wave travel faster in deep water, result in the wave being more parallel to shore. A shallow water wave speed is depend on ocean depth. If the part of wave is in a shallow water, then it will be travel slower. Now, the last question, question number 10. Under what condition are the wave diffracted the most? So, answer of this question, as the wave water goes through the gap they spared out, this called is diffraction. So the longer wavelength of the wave is the longer and the amount of diffraction. The greater diffraction happen when the gap of size is about the size of the wavelength. Now and other answer for this justification, now we can see that this is the diffraction, the extent of the separating them depend on the width of the gap of compression wavelength of the wave. Significant diffraction only happens when the wavelength is the same order of the magnitude as the gap. Okay, for the other justification of this question and other answer. Essential condition for the diffraction of light. We can see that first part, light of source should be monochromatic, or in second part, wavelength of the light used to be compressible to size the optic cell. So consider a set of parallel rays of the length L1 falling on a slit from the plane forward. So we have consider for the diffraction wave, their condition is the width of octaxle must be less than or compressible. So the length of the light will be used. Here, this is the final answer.